Hey, I want to show you another way to do example 8 if you chose not to do a trig substitution. Okay, so let's take a look at that real quick. So I'm going to go a little bit faster since we've already been through this. The derivative here is going to be negative sine y dy dx, and the right hand side is 1, which kind of is nice because here in the next lesson in 3-4 we're going to be dealing with a case where uh, you end up with a 1 in your derivative. All right, and the way Gene worked it at this point was to call dy dx, uh, just leave it negative 1 over sine y. Well, not really leave it like that. She did this. She went negative and then called it sine y to the negative 1 power. Okay, and then took the derivative of that. Okay, fine. So if I do that, instead of calling that negative cosecant, which I kind of preferred, and it's fine. That was just my opinion. I'm not saying what she's doing is wrong. It's just a different way to do it. Get the same answer that's just going to look different. All right. So then if I did power rule, so if I drop that exponent down, that makes that positive, and then I copy to a new exponent. My new exponent is going to be negative 2, and then chain rule then is in effect here. And so the derivative of sine is cosine. All right. And then the derivative of y is dy dx. Okay. Which is fine. And then, so then you end up with sine y to the negative 2. Can send that to the bottom. We'll do that in a second. Cosine y. And then this substitution. Dy dx, we just found it to be negative. I'm just copying what I wrote down right here. That we already found it. So dy dx is this. So that's going to be negative sine y to the negative 1. Oh my gosh. Yeah. Okay, there we go. Okay, so if I keep going, maybe let's move up here then. All right, and so this is equal to, you end up with a cosine on top, right? And on the bottom, you end up with 3 sine squareds. And what she said was, no, not 3 sine squareds, 3 sines. So sine cubed, okay? And that's all cool. And what she called that then was sine cosine y was x. So she said it was x over sine cubed y. All right, and that's okay. That's fine. That's not what we did, though. What we did was we had the cosine over sine as a tangent. Sorry, cotangent. So a cotangent was that cosine with one of those sines, right? So that would be cotangent, not cosine. Cotangent. Cotangent. Now let me just write the whole thing. I got room. All right, so I'm going to split it apart here. So I'm going to say I got a cosine y over sine y. Okay, and then times, and then I've got 1 over a sine squared y. Right. This is where we ended up. I mean, this is a good answer. Fine. That's pretty clean, right? But by doing a trig substitution, we ended up with this tangent, and then this was 1 over sines, which are of course cosecants. So cosecant, and there was 2 of them, right? Squared y. So that kind of shows. So going, I mean, they're about the same amount of work, I think. Maybe the other way with the trig substitution was a little bit quicker, but since you've got this kind of ambiguous way, like, did you want to go this way? Do you want to answer it like that? Do you want to answer it with trig functions? This would be a tough one for them to put on the AP exam, since there's numerous routes that you could take and have what essentially is the same answer. Okay, so I'm going to call that version 2, and you just really need one of them. If you want to just glance at this one, that would be great. And where is my stop button? I don't see it.
W. Beep, beep, boop.